Welcome everyone to my YouTube channel. Today we will discuss one important concept, that is addressing mode of computer organization. Now what is an addressing mode? So we all are aware that microprocessor executes instructions that are stored in the RAM. It executes one instruction at a time, and each instruction consists of two parts, opcode and operand. Opcode specifies the actions to be performed by the CPU. For example, addition, subtraction, move a data, increment, load and store, etc. Whereas operand are the datas or register on which the operation is performed. So operands can be a register, memory location or an immediate data. So example of an instruction is move B, A. So MOV, it represents the operation that has to be performed, whereas B and A are the operands. One more example of an instruction is add B, where ADD represents the operation that you have to perform, whereas B is the operand. Keep in mind that understanding the operations and operand is essential to learn the addressing mode, as addressing modes define how operands are accessed by the CPU. Now an operand can be stored either in the processor register or in the memory. So there are different methods used to access the operands. The method by which an operand is accessed from the register or memory is called an addressing mode. Thus, an addressing mode defines how and where the operand is obtained from an instruction. So there are different registers in the CPU, like accumulator, flag register, general purpose register, special purpose registers. Registers are very fast storage locations, and accessing data from register is much faster than the accessing memory. So there are different addressing modes which are displayed here. So let me read it one by one. The very first is the immediate addressing mode, register addressing mode, register indirect addressing mode, direct addressing mode, indirect addressing mode, implied addressing mode, relative addressing mode, indexed addressing mode, base register addressing mode, auto increment or auto decrement addressing mode. We will focus on first 6 addressing modes. The very first addressing mode is the immediate addressing mode. So in immediate addressing mode, the operand is specified within the instruction. So operands itself is provided in the instruction rather than an address. So it is not stored in any memory location or in the register. The operand is present in the instruction itself. For an example, let us see this move immediate. So MVI A, 15H. So here the data 15H has to be moved in register A, where this 15H is available in the instruction itself. One more example is add immediate ADI 3EH, where 3EH is the data that has to be moved in the A register. So A plus 3EH, this addition has to be moved in the A register. So here 3EH is the immediate operand. So second addressing mode is the register addressing mode. So in register addressing mode, the operand is specified within one of the processor register. Instruction specifies the register in which the operand is stored. So example is move C, A, where A is the operand specified in the register, and that the data is present in the A register that has to be moved in the C register. Similarly, add B. So here whatever is the content of A register and the content stored in the B register is added, and it is moved in A register. Third addressing mode is register indirect addressing mode. So here the instruction specifies the register in which the memory address of operand is placed. It do not specify the operand itself, but its location within the memory where the operand is placed. So just see an example where MOV A, M. So here it moves the data from the memory location specified by the HL register pair to the A register. So data is stored at the memory location. And where is the memory location? The memory location is specified by the HL register pair. So just see here. So example is move a comma m. So you have to move the data present at the memory location, and this memory location is specified by the HL register pair. So from here we'll get the memory location. The data that is at this memory location has to be moved in the A register. So it moves the data from memory location specified the HL register pair to A. So just take an example before. If the content of registers are A is empty, H is 28, L is 08. So the memory location is specified by HL register pair. So now what is the address forming? 2805. So we have to go at 2805. So here the data is present. So data is A9. Where you have to move this data? You have to move that data in A register. So after executing this register, what is the content of A register? The content of A register is A9. Okay. So this is register indirect addressing mode. Next addressing mode is direct addressing mode. So in direct addressing mode, the instruction specifies the direct address of the operand. The memory address is specified where the actual operand is. So let us see an example. So the instruction is load accumulator LDA 2805. So it loads the data from the memory location 2805 to A. Okay, so this is direct addressing mode. Similarly, store accumulator STA 2803. So whatever is the content at A, it will get stored at 2803. It stores the data from A to memory location 2803. Okay. So this is store accumulator instruction. Direct addressing mode. So the example we will take this LD8 2805. So whatever is the content at 2805, it will get stored in the accumulator. So let us see before. If accumulator is empty and the content at 2805 is 5C. So after this instruction, after execution of this instruction, what will get stored in accumulator? Content of 2805. So what should be in the accumulator now? 5C. Okay. So after executing the instruction, the content of accumulator is now 5C. Moving further. So just one more example of direct addressing mode. Okay. Next is indirect addressing mode. The instruction specifies the indirect address where the effective address of the operand is placed. So the memory address is specified where the actual address of the operand is placed. So for an example, move A, 2802H. So here it moves the data from the memory location specified by the location 2802 to A. So this is indirect addressing mode. Okay. So example, just see, move A, 2802H. So what it will do now? It moves the data from the memory location specified by the location 2802 to A. So now 2802 is the location. We will go to 2802. Okay. Now here what is the memory location? Now for memory location 4 bits are required. So from where we will get 4 bits? So we will need two memory locations, 2802 and 2803. Okay, so the immediate next location is taken. So 2802 it is 28 and 03 is 06. So what is the memory location? 2806. Okay. Now what is data at 2806? Let us go to 2806. What is the data? FF. So what it has to do to the data? It has to move to A register. So now after executing the instruction, what is there in A register? It is FF. The next addressing mode is implied addressing mode. It is also called inherent addressing mode. The operand is implied by the instruction. The operand is hidden, fixed inside the instruction. So example is complement accumulator, CMA. So here accumulator A is implied by the instruction. Similarly, second example, complement carry flag, CMC. Your flag register is implied by the instruction. Set carry flag STC. Your flag register is implied by the instruction. So, in this particular video, I have covered 6 addressing modes. The next addressing modes will be covered further. So, the concluding remarks are every instruction consists of an operation and one or more operands. So, I hope it is clear. Operands may be stored in register or memory. So, addressing mode defines how and from where the operand is accessed. Different addressing modes provide efficient memory usage, faster execution, and flexible programming design. Understanding addressing mode is essential for instruction execution, CPU performance analysis, and low level programming and system design. So, thus, addressing mode acts as bridge between instruction and data inside the CPU. Thank you so much.